Hey gang, hope you've all had a good day. So today we're going to keep going with equivalent expressions questions, this time focusing on questions that have you rearrange equations to solve for certain constants or variables. So we'll start with this. The period of an object attached to a spring can be found using the formula T equals 2 pi root m over k, where T is the period in seconds, m is the mass in kilograms, and k is the spring constant in kilograms per second squared. What is the value of k in terms of T and m? So this is a real physics equation, and if you've never seen it before, it might feel overwhelming. K, kilograms per over second squared, T, square root, a fraction and a square root, but it doesn't matter if you don't know this equation because all that matters is that you know the math. Right? You don't need to know physics to know math, but you need to know math to do physics. So we're just going to use basic algebraic concepts of PEMDAS and isolation to solve for K. And first, right, we'll do divide by 2 pi. So we'll get T over 2 pi equals root m over k. We want to isolate for the k, right? So we're going to square in a second. So step 2, I'll write out what we're doing. Square. So we're going to get t squared over 4 pi squared equals m over k, right? And now there's a couple of things you could do from here. You could move the k up, then move everything over. But I like, since there's so much over here and there's not that much here, what you can also do is flip both sides and get the k on top, and then we'll move the m over and just leave k alone. So let's do that. All right, we're gonna flip, and we'll get 4 pi squared over t squared equals k over m. And that is great. And then our last step, multiply. In parentheses, I'll put or multiply by m. So then we're going to get 4 pi squared m over t squared, and then m cancels, right? And we're going to get k. And that is wonderfully, it's A. And if you had taken a more active approach of looking at your answer choices, right, you could have seen, oh, when I divide by 2 pi, right, we have t and 2 pi on opposite sides of a fraction, and there's no reason that would ever get changed, so we can eliminate b and c. And then 1, 2 square, you see that you get 4, so we could eliminate d and we'll just get a. But we'll work out all the steps here and see how everything works out. Let's go to the next one. Okay, so the formula for gravitational force is F equals G, capital M, lowercase m, all over r squared, where F is the gravitational force, G is the gravitational constant, M is the mass of one object, M is the mass of the other object, and R is the distance between the objects. In terms of F, G, M, and M, what is R? Okay, so this is another physics equation. If you've taken physics, you might be familiar with it. If you haven't, that's okay. It's one of my favorite equations. It feels very intuitive to me, right? Bigger masses will create greater gravitational force, and the farther distance, the farther they are from each other, the less that force will act on them. And then G is just this constant. So let's work out what is R. So here we'll do F equals, I'm just going to rewrite it to start. And then I'm not going to flip, I'm going to multiply. So I'm going to do, I'm still figuring out what the best way is to show my work, but I think you'll understand me. So there, great. And now we're going to go divide by F, divide by F. R squared equals G M over F, which if we look at the answer choices, that eliminates B and C probably. And then we have F squared over F. So now what we need to do is square root. We get R equals square root of G M over F, which is D. Again, looks complicated because there's all these letters and there's squaring and there's fractions, but then when you start going step by step, you see that things get simple quickly. Okay, and then let's go to one more. Different script here, I know. The formula for surface area of a cylinder is SA equals 2 pi r squared plus 2 pi r h. What is h in terms of SA, pi, and r? Okay. So let's isolate h here. We can look at these equations, right? SA minus 2 pi r squared plus 2 pi r, 2 pi r parentheses times SA minus 2 pi r squared. Okay. And then we have surface area minus pi r squared divided by 2 pi r. Okay. And then surface area divided by 2 pi r minus r. Okay. So I'm going to rewrite it just to get a rhythm with it. But on the actual test, you don't need to rewrite it. You could maybe even do almost all this in your head. Now, you want to do reverse PEMDAS, right? So we're going to subtract. We'll get surface area minus 2 equals surface area minus 2 pi r squared equals 2 pi r h. And now we want to divide by 2 pi r. Divide by 2 pi r. So then our answer is h equals SA minus 2 pi r squared over 2 pi r. But if you look, we don't have answers like that, right? We do have a fraction. So that's probably going to be C or D. So you can probably cross those out. But we don't have it written like this. So we have to keep going. If you notice, we can simplify this part, but we can't simplify here. So we'll keep SA over 2 pi r. And then do minus 2 pi r squared over 2 pi r equals h. And then we'll simplify that part. SA over 2 pi r minus the 2's cancel, the pi's cancel, and this partially cancels r equals h. So let's go back up. And that is D. Okay. So if you see how that one worked, it had this addition subtraction. And then whenever you have addition and subtraction all being divided by the same thing, you can normally just write them all together under one big fraction, or they can't all be simplified. But sometimes the SAT, to throw you off, might simplify part of it and break up the fraction again, like they did here. And you'll get D. All right. Well, as always, let me know if you have questions or comments. Any feedback would be great. And yeah, if there's any other type of material like this or different that you'd like covered, let me know. And it'd be great if you could like and subscribe. Thank you.